Today's video is going to be about systems of equations, and this time we're going to talk about a different method called the elimination method. Here are the steps for the elimination method. If you'd like to pause here and write these in your notes, you're welcome to, but we're just going to dive right into some examples and use these. So we have two equations, and the goal is to find the solution, and the solution would be a point that satisfies both equations. And so we need an x and a y value that work when we plug them into both of these equations. If we were thinking about a graph, this would be the point where they intersect. So our first step is to line up the equations. So line up the equations. That means that the x's need to be in a column, the y's need to be in a column, and then the numbers need to be in a column. And the equal signs also have to be in the same spot. So these are already lined up for us because they're in the same order. So we've already completed number one. Multiply one or both equations by a number to result in a variable with the same coefficient. So what we're seeing here is we have a 1 and a 1, we have a 7 and a 1, and then these don't matter. So our x's already have the same coefficient, so we're going to say that that's done. Now, add or subtract the equations to eliminate this variable. So we have x and x. If we add those, we're going to get 2x. So we want to subtract those. So what we have to do is we subtract the two equations, but instead of trying to do it that way, we're going to go ahead and distribute that negative so we don't get confused. So this equation will stay the same, but this equation is going to become negative x plus y equals positive 7. I guess you don't have to write the positive. And now we can add these together. So once we've distributed that subtraction, we just add these up. So x plus negative x is 0. 7y plus 1y is 8y. And then 17 plus 7 is 24. So now we have this equation, 8y equals 24. And we want to solve that for y, so we're going to divide both sides by y, and we're going to get that y equals 3. And if you look over here, we had eliminated one variable by adding or subtracting. Now we want to solve for the remaining variable. So that's what we just did whenever we got y equals 3. So now what's left is to substitute our answer from step 4 into one of the original equations to find the other variable. So it doesn't matter which equation we choose. I think this one looks easier because there's no coefficient next to the y. So that's the one I'm going to choose, but it really doesn't matter. So we have x minus y equals negative 7, and we want to plug in 3 for y. So x minus 3 equals negative 7. Then we will add 3 to both sides to solve, and we get x equals negative 4. So those are the two pieces to our answer, but the way we should write our final answer is as a coordinate pair. So it's always parentheses, x, comma, y. And this is your actual final answer. That's what you want to get to. This is one of those videos that once you have the hang of it, if you want to work ahead, that's fine. But you should come back here to check your answers and make sure that you understand exactly what you're doing. So we're going to just start from step 1 again. First, we want to line up the equations. So we have x's, we have y's, and we have constants on the other side. So now we want to multiply to get a variable with the same coefficient. So x's have 3 and 5. Those are not the same. But y has 2 and 2. So those are the same. So we don't have to do that step either. Now we want to add or subtract the equations to eliminate the variable. So we're looking at the y's because they have the same coefficient. If we add 2 and negative 2, that's going to give us 0 and cancel that and eliminate that variable. So we can just go ahead and add these together. We're going to get 8x plus 0 equals 64. So that just simplifies to 8x equals 64. And then we will divide both sides by 8 to solve for x. And we're going to get x equals 8. So we have done steps 3 and 4 now. Now we need to substitute our answer from step 4 back into one of the original equations. Again, it doesn't matter which one you use. I'm just going to pick it randomly. And we have 3 times x, but we want 8 to be plugged in for x. Plus 2y equals 22. So 3 times 8 is 24 plus 2y equals 22. Then we have to subtract 24 from both sides, and we get 2y equals negative 2. And finally, divide both sides by 2 to find that y equals negative 1. And again, we have to write our answer as a coordinate pair, 8 comma negative 1, and that's the final answer that you want to have. All right, so in this problem, number 3, we are lined up. So now we need to get a same variable. So here we have 4 and 1, and then 9 and 5. So you want to think about the smallest number you could use to do this, because the bigger your numbers get, the more the more work you have to do, which is not a huge deal. But the easiest thing we can do is turn this 1x into a negative 4x, because whenever we have a negative 4, then we can just add these two together and it'll cancel. So I'm going to multiply everything in this equation by negative 4. So this one will stay the same. I'm going to rewrite it just so we have everything lined up in the same. We have 4x minus 9y equals negative 42. And this equation is going to become negative 4 times x, that's negative 4x. Negative 4 times 5y is negative 20y. And that's going to equal negative 4 times 4, which is negative 16. So now we can add these two equations together. So 4x minus 4x is 0, so I'm just going to mark those out. Negative 9 minus 20 is negative 29y, and then negative 42 minus 16 is going to give us negative 58. So now we want to solve, we've done this. Now we want to solve this equation for y, so we divide by negative 29 to get y equals positive 2. So we have one of our variables, and now we need to plug that into either of the original equations to find the other variable. I'm going to choose this bottom one because it looks like smaller numbers. So we have x plus 5 times 2, because that's what y equals 4. So this is x plus 10 equals 4. Subtract 10 from both sides, and we get x equals negative 6. So our final answer in this proper form is negative 6, comma 2. Our next problem you'll see is already lined up, but when we go to multiply, none of our coefficients are 1, so we're automatically out on that easy of 1. But if you look at what our possibilities are, we see that we have 6 and 3 here, and if I multiply 3 by 2, I get 6. If I were going to try to do something with the x's, I would have to multiply 7 by 2 and 2 by 7 to make them both 14, because there's no way without using decimals and fractions to get 2 to equal 7 in an easy, even way. So we are going to multiply the bottom, and I actually want to change this sign as well so that it all cancels out and it's one easy step. So I'm going to multiply this by negative 2, and that's just going to flip every sign for me. so that I can just add these equations together and go on. So once again, this equation is not going to change. We have 7x minus 6y equals negative 53. In this equation, we're going to distribute the negative 2. So we're going to get negative 4x plus 6y equals positive 26. And our y's will cancel. We designed it that way. And we're going to get 3x is equal to negative 27. So then we want to solve for x, so we'll divide both sides by 3 to get x equals negative 9. Then we will substitute that back into either equation, doesn't matter which. I'm going to choose the second one. So 2 times negative 9 minus 3y equals negative 13. We get negative 18 minus 3y equals negative 13. Then we will add 18 to both sides to get negative 3y equals 5. Finally, we will divide both sides by negative 3, and we will get y equals negative 5/3. And it is okay to get fractions. Fractions are not bad. So we get negative 9 comma negative 5/3 for our final answer. Problem number 5 is similar to the last couple that we've done, but if you notice, this time we don't have neither variable has coefficients that are easily converted to one another. So what we can do is we want to find the least common multiple, or the smallest number that both coefficients go into easily, or evenly. So if we were to do 3 and 7, let's look at multiples of 7. So 3 does not go into 7 evenly. 7 times 2 is 14, and 3 does not go into 14. But when you do 7 times 3, you get 21. So we would have to multiply this whole equation by 3 and this whole equation by 7 if we use those. However, if we do the x's, the smallest number that 2 and 5 both go into is 10. So we'd have to multiply the top by 2 and the bottom by 5. And these are just smaller numbers. And in my mind, the smaller you can keep the numbers, the more simple the problem's going to be. So I'm going to choose to use the x values. I want to cancel the x's. In order to do that, I have to multiply this whole equation by 2. And that's going to give me positive 10x over here. And then I'm going to multiply this equation by negative 5 because I want to get a negative 10x here so that they cancel each other out. So let's look at what this is when we rewrite it. So when we distribute that 2, we have 2 times 5x is 10x, 2 times 3y is 6y, and 2 times negative 7 is negative 14. And then we're going to distribute our negative 5, and we're going to get negative 10x minus 35y equals negative 15. And we can add these two together. So our 10x and negative 10x cancel each other out. And then 6 minus 35 is negative 29y. And negative 14 plus negative 15 is negative 29. So we want to solve for y. So we will divide both sides by negative 29. And we get y equals 1. So then we substitute y into either equation. I'm going to use the bottom one this time just for fun. So we get 2x plus 7 times 1 equals 3 because y equals 1. 2x plus 7 equals 3. Subtract 7 from both sides. 2x equals negative 4. Divide both sides by 2 to get x equals negative 2. So when we write our final answer, we have negative 2 comma 1. Number 6. Everything is already lined up. We need to just start by multiplying. So let's look at these. If we were to use 3 and 4, the smallest number that both of these go into evenly is 12. So we would have to multiply by 4 here and by 3 here. If we use 9 and 12, I always like to look at the biggest number because we're going to get there faster that way. So if we use 12, 9 does not go into 12. The next one would be 24. That does not work. The next one would be 36. And 9 and 12 do both go into 36. You would multiply the bottom by 3 and you would multiply the top by 4. So it looks like we're going to do the same thing to cancel out either set of variables, which is kind of an interesting thing. So let's see exactly what happens when we do this. So if we're going to multiply the top by 4, for the bottom, we want to change the signs because we want these to cancel. So we're going to multiply by negative 3. And as we distribute those, we get 12x minus 36y equals 36. And we get negative 12x plus 36y equals negative 108. So we're going to add these together. 12x plus negative 12x is 0. Negative 36y plus 36y is 0. So 0 plus 0 is just 0. When there's nothing to put over there, we're going to just put a 0. And 36 minus 108 is negative 72. So now we have a problem. Our variables disappeared on us. So when your variables disappear like that, you want to look at this statement here. This says 0 equals negative 72. And you ask yourself, is that true? And it's not. 0 is not equal to negative 72. So what that means is there is no solution for this set of equations. If this were true, then you would have infinite solutions. So, true statement is infinite solutions. A false statement is no solutions. So this is false, so we have no solutions. All right, for number 7, we finally have one that we need to reorder some. So let's look into that. This equation is already in the normal order. We call that standard form. This equation needs to be moved around. We need to subtract 2x from both sides to get that over there. So since I want it to be in this order, I'm going to put the minus 2x out front. And then this is a positive 7y, so it's plus 7y. And that's going to equal the positive 8 that's left over here. So now is when we need to look at our coefficients and see which ones we want to use. I'm going to choose to multiply this whole equation by positive 2 and this whole equation by positive 5. Because if you notice, the x's already have opposite signs, so we don't have to change any signs here. But this will make both of the x's have 10 as a coefficient. So I'm going to put, because we're not adding yet, I'm going to put like a squiggly line so that we know we're just changing the form of the equations. And we're going to start with the top one and distribute that 2 to get 10x minus 12y equals 6. And on the bottom, we'll distribute the 5 to get negative 10x minus, oh, nope, we're not changing the sign, plus 35y equals 40. Now we can add these together. So that's going to give us 0. Negative 12 plus 35 is 23y equals 46. And then we want to divide both sides by 23 to get y equals 2. And then we're going to plug that into either equation. I'm going to choose the second one. It really doesn't matter. You can do whichever one you want. And then we want to solve for x. So actually, instead of doing that first, let's multiply 7 and 2. So 14 equals 2x plus 8. We're going to subtract 8 from both sides to get 6 equals 2x. And then divide both sides by 2 to get 3 equals x. So But the way that we write our final answer is going to be 3, 2. And the final example for this video is number 8. We are going to first put things in order, line up the equations. For this one, we want to move the 8y to that side and move the 18 to this side. Or why don't we do it this way? No, that's right. That's fine. So when you move something across the equal sign, you change the sign of it because we have to add that 8y. So this is going to change to the 10x stays where it's at. So we get 10x. We have to add the 8y to get it to the other side of the equation. So plus 8y equals, and we'll have to subtract the 18 to get it to the other side. Now we want to change this one. We're going to kind of do the same thing. So we already have the 9x on the left. We're going to leave it like it is. We want to subtract 5y to move it across the equal sign. And then to get the 4 to the other side, we have to subtract it. So these are our new equations. And we want to decide on something to multiply them by. I chose to use 9 and 10. And so I multiplied the top by 9. And the bottom by -10 because I need to flip this sign in order for them to cancel. So, squiggly line because we are not adding them together yet. We distribute that 9 on top and we get 90x plus 72y equals -162. Then on the bottom, we're going to distribute that -10 to get -90x plus 50y equals +40. And when we add these together, these are going to cancel, and we're going to get 122y equals -122. We'll divide both sides by 122 to get y equals -1. Now we will plug that into either of the other equations. I choose this one, and we want to solve for x. 5 times -1. So we have 4 plus 9x equals -5. We want to subtract the 4 from both sides, and we'll get 9x equals -9. And then we will divide both sides by 9 to get x equals -1. So actually our coordinates are equal to each other. And our answer is -1, -1. Thanks for watching. Have a great day.